Hello, everyone. Thank you for joining our session today. This is the Canary Deployments with Consul Service Mesh on Kubernetes. I'm very happy to have you all today. My name is Krastev. I am a product education engineer at HashiCorp. I am specializing in Consul, and today I'm here to talk to you about how to perform Canary deployments in your Consul Service Mesh. This is the content of our presentation today. We're going to start off with a short intro in terms of what we have in our technology stack for our presentation and for the demo. We're going to move on to the architecture of our environment. What are we using? What have we deployed and where and how? After that, we're going to have a short description on what application we're using in our environment. This is going to be HashiCups for this specific case. And we're going to go over the several microservices and ways that the HashiCups as an application functions and performs. After that, we're going to explain the concept of Canary deployments from origin of Canary deployments all the way down to how to do them. And after that, we're going to have a live demonstration on how to perform these in Consul Service Mesh. We will conclude by going over the contents of what we learned, in addition to mentioning some considerations for performing Canary deployments in production environments and other things that need to be kept in mind when performing, planning, or accommodating for Canary deployments. Without further ado, let's jump right in. Our technology stack today consists of a few moving blocks. Of course, at the center of our presentation is the HashiCups sample app. HashiCups is an online store for coffee that you will see shortly. It's a simple microservices-based application that we're going to make use of. HashiCups will use the Consul Service Mesh in terms of networking connectivity between its microservices, and both of them will be deployed on top of a Kubernetes platform. Kubernetes flavor is going to be EKS and will run in an AWS instance in a cloud. Now, let's jump right into HashiCups itself. HashiCups will run into this environment. We're going to start off with a simple Kubernetes cluster running on AWS, the EKS Kubernetes cluster. For this specific example, we're going to use just one node to keep the explanation simple and straightforward. On this node, we're going to add a VPC peering so that the EKS cluster can connect to HCP console. For this demonstration, we are going to use Consul in the HashiCorp Cloud Platform, and we are going to connect our clients running in EKS to it. These clients are going to be deployed in the EKS pods, and you can see that the several microservices that comprise of HashiCups, including front-end and API backend, are going to have a sidecar container running Consul data plane. It is worth noting that with version 1.14, Consul for Kubernetes no longer requires that you run clients within the Kubernetes cluster. The new feature called Consul data planes is going to make the workload lighter by just injecting a Consul workload into the sidecar container for each pods that you decide to be available of the Consul Service Mesh. Naturally, if you run Consul version 1.13 and lower, you will have to deploy Consul clients in your Consul Kubernetes environment. With this explanation out of the way, we're going to step over into the HashiCups application itself. HashiCups is a sample application. It is a web shop for coffee. It has a few moving blocks. You can see that the first point of entry for HashiCups is a reverse proxy that uses Nginx specifically. We use that just so that we have a little bit more control over incoming requests in this application, though if you so decide to, when you try this lab in your own environment, you can skip that. After that, we have the so-called front end of HashiCups. This is a very standard version front end. It deploys with a microservice workload, and it uses a few upstreams in which public API and products API. These two API microservices connect to the database and to the payments microservice. And this is the whole setup of the HashiCups microservices application. In our case, as you can see in this diagram, HashiCups is running on top of Consul Service Mesh in our already deployed Kubernetes cluster. Now, moving on, what are Canary deployments and where do we use them? Canary deployments is a technique in IT rollout that lets you perform gradual software and application releases so that you mitigate and you control the risk that comes connected with deploying new versions of your software. When we say Canary deployments, that is the first thing that pops up to mind, at least to me. But the term and its origins are very interesting and unusual. It actually came out from miners working minefields. And because they were very dangerous places with chances of leaking gases, which were lethal to people, they were forced to take down canaries with them because apparently canaries are much more sensitive to these dangerous gases. And unfortunately for the animals, they were used as a designation for when it was too dangerous for a person to stay down there. Now, luckily for us, our deployments no longer involve any kind of similar treatment to canaries. So let's move on into defining what actually a canary deployment is and how does it help us mitigate risk in running that in our environments. Now, imagine, if you will, an ingress point into your application that gets routed and hits a specific current version of your platform. We would like to introduce another version, be it for new functionality or be it for new feature set or for beta testing or for new UI testing, it doesn't matter. Then we introduce this new version, and so far the traffic is going towards the current version. 100% of that traffic is going to the current version. Now, here we are set up with a challenge. How much traffic do we send over to the new version? Obviously, we could send the whole of the traffic there and just decommission the current version. But this holds a few certain risks. If there's any bugs or if there's any problems with the deployment, immediately switching all traffic to a new version is going to impact all traffic to the platform. Here's where Canary deployments step in. With Canary deployments, we just route a part of all of the traffic hitting our application so that we can test the waters and see if anything happens with the new version of that deployment. So the next step would be to split traffic here to a predetermined value. And in our case here, we're going to send only 30% of traffic to the new version. Now, this is a simplistic definition of canary deployment because this takes a mathematical approach to all the requests and sends them randomly, 30% of them to the new version. Ideally, in a production environment, you will have users signing up for beta functionality testing, and this will be the flag that will decide whether they're going to get routed to the new version or not. But for our demo, we're going to take the easier, more simple approach and do that. Now we have 30% of traffic hitting our new version, and we need to check very carefully our monitoring solutions and maintain the observability of our product, see if there's anything going wrong. And once we're sure that the new deployment is functioning correctly, we can move all the traffic over to the new version. After which, we can decommission the old version, and the whole procedure can repeat again once we have a new version enabled. This is the final state of a Canary deployment. In this step, new version becomes current version, and the process repeats again. Now, we just explained how Canary deployment work in general. How does that work in terms of Consul Service Mesh? Well, the process is the same. However, the moving code and the specific tools that we use to implement it are slightly different, and we're going to go over them right now. Obviously, we have a routing decision splitter called a service splitter, and we also have a so-called service registrator that defines the different services. So let's step right into and see what the service resolvers are. Service resolvers are basically a way to distinguish a subset of services. In terms of Canary deployment, these can mean that the service subset has a new version of your platform or has a different UI. In any case, the service resolver helps you distinguish subsets of one service between themselves. Once you are able to distinguish subsets between a set of services, you can use service resolvers not only for Canary deployment, but also for other additional traffic management, some of which can be load balancing, some of which could be specific redirection, and most of all, some of which can be failover to a different data center or region in case of an impact. Service resolvers in our example here represent the two defined versions of HashiCups frontend. We're going to see shortly how exactly these are defined. The next step that we need to know about before we configure Canary deployments in Consul Service Mesh are the service splitters. Service splitters basically are a simple tool that does, as its name implies, they help you split traffic over a certain amount of predefined services or subsets thereof. In our case, we're going to see that service splitters are the tool we use to decide how much traffic goes between which service and which version of the service that we configure. Now, with that in mind, let's go back to the diagram for Canary deployments with Consul. Hopefully that makes a little bit more sense to you now, but the whole idea of service splitters for using Canary deployments is that you will have a service splitter tool predefined that you can configure to route different parts in different sections of traffic to different versions of your application. And with that in mind, it's time for a demo. Let's do that and let's see how service splitters, service resolvers, and how Canary deployments work with Consul Service Mesh. Now, as you already know, we have a Kubernetes environment with Consul. Yes, Consul, and I have already pre-configured that for you so that we don't have to waste time. I have Consul deployed onto the Kubernetes environment, and we're gonna take that and we're gonna run these two commands. They're going to configure our environment here to access the Consul clusters and the client via HTTP. We're going to run Consul members to make sure that our environment works, and that's true. You can see that I have a couple of nodes running in AWS, and I have my data plane clients connected to that. Now, let's open up the app UI and the console UI so that we can check visually how the status of these is. We're going to use this link to navigate to the HashiCups UI. And here is the HashiCups demo application for you. You can notice that we have a bunch of different coffee versions. You can click that. You can look at the product options and the informations. And we can also make a mock purchase should we decide to. Once we go back to the main page, if you scroll down, and I'm going to zoom in for you, just like this, you can see down here that we are hitting HashiCups version 1. We're going to have 2 versions for the front end, and we're going to use our Canary deployment guide to distinguish between these 2 versions. Now, let's open the console UI as well and check out the services there. I will copy this link here, and I will open it. And I will also log in. I'm going to copy my token. I'm going to log in with it. Perfect. Now, we can see that the microservices of the HashiCups application are listed here. And we can see that in front end, we have 2 instances. This is because I have, again, pre-deployed 2 versions of the front end so that we don't have to wait for deployments. If we look at this one, you can see that the name is just front end, but if you look at this one, you can see that this one is version 2. So every time traffic would hit front end version 2, we'll be able to see it in our HashiCups UI listed here. Now, let's go back to our terminal and let's start configuring the HashiCups Canary deployments. At first thing, we're going to check out the service definitions in console. You can do that via the terminal as well, also via the UI. So if we run this, you're going to see that we have exactly 2 front-end services. One has the tag version 1, and the other one has the tag version 2. This is also visible in the console UI. So we can go here to services, front-end, and the instances. And for example, to check the one with version 2, if we click here, now we are in version 2 service instance. In tags and meta, we're going to see that the tag called version equals the version 2 value. Okay, now we're going to go back here and we're going to do the following. We're going to create the service resolver. Again, service resolvers are the function of Consul Service Mesh to help distinguish between the 2 console service versions. In this case, the 2 HashiCups front-end definitions. So if we open this file that I have pre-populated to you, you can see that this is the Kubernetes CRT and 2 subsets of the front-end instance are the ones that are distinguished between the services meta version tag, and v1 becomes v1 and v2 becomes v2. We're going to upload this configuration to console. Perfect. And if we'd like to see, we can also take a look at the service definition in the UI. If we go to routing, we will see that in resolvers, we now have v1 defined. Now we're going to configure a splitter that is going to take 30% of the traffic and send it to version 2 of the front end. We're going to take this file, and you can see that this is a service splitter configuration. It defines a split between service subset v1 and service subset v2. with V1 taking 70% and V2 taking 30%. We're going to apply this configuration. And again, once we go to the UI, we can see that now we have two versions, and also a service splitter has been configured. And this splitter, when I click it, splits traffic between V1 and V2. And if I hover over the line, you can see that 70% gets to V1 and 30% goes to V2. Now, if we refresh the UI, for 1/3 of the chances here, we're going to see HashiCups V2. There we go. After 3 refreshes, we see V2. This way of checking, however, is a little inconvenient. So what I have done for you is a little script that just opens up the URL for HashiCups and takes a look at the string at the footer of the page. So I'm going to run this. And you can see that more or less every third time we hit version 2 of HashiCups frontend. Yes. Statistically, more or less every third time. There we go. I will stop this. Now, in this case, if this is a production environment, this will be a very important moment to observe all the metrics, all the observability, all the monitoring suites, all the transactions and everything related to your platform and your application. This is your testing ground to make sure that the application in its new version is performing as expected. Now, if we decide that this is the case and we would like to continue with this deployment and remove all the traffic to the new version, we're going to do the following. And this is another file that I have created for you. This takes the front-end service splitter and configures that 0% of the traffic is going to go to version 1 and 100% of the traffic is going to go to version 2. What we're going to do is we're going to configure that. And now, if I start my script, we should only see HashiCups front-end version 2 being queried. Let's give it a few seconds and make sure that there's no statistical routing or anything else going to version 1. Yeah, I think this is successful. Now, at this point in time, we have completely migrated all our traffic to version 2. If we go back to the UI of Consul, and if I hover over line here, you can see that 0% of traffic is going to V1 and 100% of the traffic is going to V2. The last step of this Canary deployment would be to now delete the definition of service resolver for V1 and then go back and decommission the services that are actually running V1. Of course, in a continuous integration or continuous deployment pipeline, this should all be automated and should not be a manual process. And after this is how you do Canary deployments with Consul Service Mesh and Kubernetes. Now, for the cleanup, we're going to delete the service splitter, and we're going to delete the front-end resolver as well. Now, if I check again the services instances and the service routing, you can see that the splitter is gone and the resolver configuration is gone. We have effectively reverted our Canary deployment in a way rolled back right now. Yes, so let's go back and jump back into our presentation. Conclusion time. What did we just learn? We learned that deployment of software can be made in a step base. It can be rolled out slowly with a slight amount of traffic hitting the new version so you can test it with either a target group or statistically a random piece of group. We've learned what a Canary deployment is and how to perform it with Consul Service Mesh. We've learned about the configuration elements of Consul Service Mesh on Kubernetes that help you perform Canary deployments and other traffic routing configurations that you might want to do. And we also have learned a few considerations for production environments on what to perform during the traffic rollout, where to pay attention after that happens, and how to complete the transition and make sure that the product environment of your application is running in a correct state. The important thing for this case is monitoring and observability. It is very, very important to have a proper monitoring set up for Canary deployments, because monitoring is essentially your test of whether your deployment has been successful or not. This is the way that you can leverage the power of Canary deployments. And if there are any issues with your deployment code or application's new version at all, this will be the time to find them so you can mitigate the risk, close down the impact, and make sure that any kind of issues do not bring down your whole environment for your customers and your service. Now, if anybody has any questions, please direct them to the YouTube comment section below, and I'll answer all of them as much as I can, as many as I can possible. And if you want to test the code for yourself, please go to developer.hashicorp.com and search for Canary deployments. You will find a guide there with all the source code that you saw here and all the configuration. And you can log in, create your own HCP cluster with Consul. It will give you a nice Terraform module code that you can run. You can deploy that and put it either in Amazon or Azure and make your own environment, and you can test everything that we did here on your own time and make sure that there's no secrets left for you to discover after that. Yes, if you have questions, again, direct them to the comment section. And with that in mind, thank you for attending this presentation. For any questions about it, please email hugs@hashicorp.com, as you can see here. Go to the webpage, try all the code for yourself. And if you need any help, if you have any further questions after that, please go to discuss.hashicorp.com and post there. We'll be happy and glad to help you out with all that. Yes. So thank you guys, and very happy that you were here today with me. I hope to see you again on the next HashiTalks presentation. Bye-bye.